Now, while we're talking about mixtures, there are a few very useful laboratory techniques for separating mixtures. And this will be useful whether it's a heterogeneous or a homogeneous mixture. The first is filtration. This is a very common case where I have, in this case, it would be a mixture where I have a liquid component and a solid component, and they're not even, the solid's not dissolved in the liquid. And so I have, and this would be an example of if you took a scoop of ocean water, for example, and you had sand in there and you had water. Well, the sand is not dissolved in the water, so you've got solid and liquid in the same sample. To separate those out, we can simply put a piece of filter paper in a funnel and then pour that solution down through. Solid material is retained on the filter paper and liquid material flows through and is collected beneath. And this is a very useful way for separating mixtures of solid and liquids. Another extremely useful method of separating mixtures, and this is particularly applicable for homogeneous mixtures, for solutions. So something like seawater. Now we filtered it. Say we took that scoop of initial seawater that had some sand in it. We did a filter. We got out all of the solid material. But then we had seawater, which is a homogeneous mixture. We can use distillation to separate out the components of that homogeneous mixture. Distillation works by taking the liquid homogeneous mixture and heating it up here to boil it so that the liquid will boil and will travel up as a vapor. Now we transfer it from the liquid phase to the gas phase. It travels up above here and goes down the sidearm tube, where it then hits a cold tube. So we have a tube flowing down from the sidearm down to the collection flask, and around that tube is another jacket, is a small jacket where we flow cold water in, and that cools the jacket. And so when the hot vapors hit that, they condense back into the liquid phase and then flow down into the receiving flask. Now, only the liquid component of that mixture will evaporate. Only the water vaporizes. Solid components that may have been dissolved won't vaporize. And so the salt remains behind. And so if we just continue to do that until we have removed most or all of the water, then we have separated out this homogeneous mixture. Water in one area now, and we've left the salt or sea salt in our example behind. And that's a very, very useful way of separating homogeneous mixtures. There's another very common technique for separating homogeneous mixtures. This is known as column chromatography. Now, column chromatography separates compounds. This would be extremely useful for a homogeneous mixture that doesn't just contain liquid and one component. It might contain a liquid with 4 or 5 different components dissolved in it. And so it separates them based off of their different interactions with a solid phase. So we would take a column of some kind, generally a glass column, and at the very bottom of that column, you'll notice that there's a little kind of stopcock here, which allows me to open or close, allow things to flow through or not. And we would pack the very bottom of that column with glass wool. That just prevents any solid from coming through. And then we pack a solid phase onto that. This is known as a stationary phase. It might be some kind of gel or some kind of solid sandy-like material that we put in there. And then on the very top of that solid material, you now take your mixture. Whether it could be a homogeneous mixture, it could just be, it could even be a heterogeneous mixture or a homogeneous mixture of solid material. But you put it on top of the packed stationary phase, and then run some liquid down through, some solvent, which will partially at least dissolve those components. And as it travels down that stationary phase, as it travels through that gel, down through the column, those different compounds will interact differently with that stationary phase. Maybe one compound will interact strongly, whereas other compounds will not interact much at all. And that will affect how quickly each compound travels down the column. And you can then separate those compounds based on their different interactions and how quickly they flow down the column. And so then you can collect, and if compound C travels down the column the fastest and gets down here first, you could put a beaker underneath and collect just compound C, and then you could switch out that beaker, put a new beaker in and collect compound B, and then put a new beaker in to collect compound A, and then you would be able to separate those three mixtures. That's a very useful and very common way of separating mixtures.